Welcome to another video on the series where I am pointing out the mistakes students usually make in different exams. This time it's the turn of Probability and Statistics 1. The first mistake is about cumulative frequency graphs. Okay, when we have a group data, let's say 0 to 10, 10 to 20, and 20 to 30. To make it easy, just 3 of them, and the frequencies are 7, 10, and 5. So the cumulative frequency, this is the frequency. Cumulative frequency will be 7, 7 plus 10, 17, and 17 plus 5, 22, right? So when you plot the points, usually sometimes students take the midpoint of this 0 to 10, which is 5. The midpoint of 10 to 20 is 15, and 20 to 30, the midpoint is 25. The point they plot on the cumulative frequency graph, which is like this. In horizontal axis, we have the data, and here we have cumulative frequency. So they plot 5 with 7, 15 with 17, and 25 with 22, which is not actually that wrong, but in Cambridge exams, we plot against the upper interval boundary, which is 10 and 7. So first one will be, if this is 10 and this is 5, 10, 15 and 20. So first one will be 10 and 7, not 5 and 7, upper limit of the interval and the frequency, cumulative frequency. Second one will be 20. The upper limit is 20 here and 17. So 17 will be somewhere here. And then 30 and 22. 30 and 22. This is how the points should be plotted. The upper boundary limit with the cumulative frequency. Here is the summary of what I said. So we have to focus on upper boundary limit against the cumulative frequency. Let's go to the second mistake which people make is all of them versus none of them. It is actually about going into detail. If you read a question that there are several people, let's say that there are 7 people, okay? We want to make them stand in line, 3, 4, 5, 6, 7, all of them in a line. So that there are 3 brothers, all of them must not be together. They're saying all of them must not be together. That means 2 of them can be together. That's what it means. And what we take this as, that none of them is together. So when they say all of them are not together, we will do what? We will consider them, that all of them, all 3 brothers are together. So brother 1, brother 2, and brother 3, they are together and we will move them together, right? So in how many ways can this be done? This is one space. Now these 3 are together, moving together, they become one space. 3, 4, 5 factorial. 5 factorial ways they can be arranged, and within this box, they can be arranged 3 factorial ways, right? But they're saying all of them must not be together. But here we have made a box here, and then we don't want this case. So we'll subtract this many cases from total number of cases. Total there are 7 people, so 7 factorial ways they can stand. From 7 factorial, we'll subtract this and we'll ensure that all of them are not together. It means 2 of them may be together, right? Whereas when they say none of them together, that means even 2 of them cannot be together, right? So if you get this word none of them together, then you take a different approach. We can't use this one, all right? In that case, what do we do? In such a case, we will exclude these 3 brothers from the counting. So 1, 2, 3, 4. Only 4 other people will stand in 4 factorial ways, correct? Now we will talk about these 3 brothers. We don't want none of them. We want none of them to be together, right? So we take the spaces between these 4 people who are already standing somewhere. So we have 5 spaces possible, right? So out of those 5 spaces, we'll give 3 to the 3 brothers, and they will not be together because there will be someone between them. Some of the dots will be vacant, but it's okay. Two of them to be specific. So this will be the answer. I used P because the order in which these three brothers stand is important. So since order is important, we use permutation, not combination. So these two will give you different answers because the cases are different. And here is the summary. All of them, if they are not allowed to stand together, it means some of them can stand together. Okay, so use different approaches for different words which are used in the question. All right, let's move on to the mistake number 3, which is about proving or showing that two events are independent or mutually exclusive. Some students get confused how to prove this. It is very simple. For independent, in the events when both of them are happening, which is intersection of the both, should be PA multiplied by PB. So find the probability of their intersection, find their individual probabilities, multiply the individual property. It should be equal to their intersection. They are happening together, right? If that happens, it's an independent, they are independent events, okay? But in mutually exclusive, the intersection of two events, probability of A intersection B must be equal to 0. There should not be any common case between the two events, and if one happens, the other cannot happen. In English too, you can also say that mutually exclusive means they are exclusive. They are the only one that is happening, the other one is not happening. And independent means the one does not affect the probability of the other one. And in that case, whenever that happens, we take an event A, then happens event B, and if they are independent, we just multiply their probabilities. That's what we do here. Let me give an example. The probability of rain in the month of May can be 0.2 every day, right? So the rain on one day and rain on the other day are not dependent on each other. So they are happening one after another, and their probabilities are not affecting each other's probability. So that's why those 2 days rains are independent events. Whereas in mutually exclusive events, the intersection is always equal to 0. For example, in a bag, we have several oranges and several apples. So we take out one fruit. It's not possible that we get apple and orange at the same time. They cannot happen together. That's why they're called mutually exclusive. Two events which can never take place each other. That's what this equation means. Their intersection is 0. Mistake 4. Sometimes you get a situation where there is a spinner with numbers 1, 2, 2, 2, 3, 4. And then you have one more spinner with 1, 1, 2. And they ask you that the score of the two spinners are added, and then you get the final score. So in this case, you can see that the 2 is 3 times. Here the 1 is, and here 1 is 2 times. So the probability of getting 2 is higher here, and probability of 1 is higher in this case. So sometimes you try to do this way, that the probability of 1 in this spinner is 1, 2, 3, 4, 5, 6. 1 out of 6. Probability of 2 is 3 out of 6, and so on. Similarly here. So my suggestion is this may cause some kind of miscalculations. So best would be that you count them separate. These two, and these two. Count them separate and make a table out of it. So 1, 2, 2, 2, 3, 4 in one row, and 1, 1, 2 in one row, and then make a table to see what is the final outcome out of them. For example, 2 and 1 will give you 3 because the sum of the two outcomes is your score, right? And this is how you will have how many? 1, 2, 3, 4, 5, 6 times 3, 18 outcomes possible. and your probability will be straightforwardly out of 18. There is no need to write 1 over 6 or 3 over 6 or something like this. That will complicate things. This makes the thing simpler. So if this 3 is the only 3 in this table, no, this is not the only 3. Let me actually do it. So 3 here, 2 and 1, 3 here. And no one else will give you this. There are 1, 2, 3, 4. 4 out of, probability of 3 is 4 out of 18. Finished. So counting, make it so easy. So here's the summary. Never combine similar outcomes together. When two different outcomes result in a score, make a table that will make your job easier. Okay, let's move on to mistake number 5, which is about conditional probability. And usually this is the situation. There are two events. Their probabilities are 0.4 and 0.6. Those events are A and B. After they have happened, with A, the probability of C and D is these two, and with B, the probabilities of C and D are 0.3 and 0.7 given. And the question usually they give is probability of B given D. So you can see in this tree diagram, D happens after B has already happened. But they give you this kind of situation that it is confirmed that D happened. What is the probability that it was B which happened before that? That is the question. But what students mistake it as that D, given that D is happening, so 0.7. What is the probability that B happened before that? 0.6. Answer is 0.42, which is according to them, according to the students, okay, which is completely wrong. This 0.42 is actually probability of B intersection D. That B and D happened one after other, that is 0.42. It is not B given D. The formula for B given D, you might have done in your classes as well as it will be given to you. It is probability of B intersection D given divided by probability of what is given D. So B intersection D is known to us now 0.42. We have to find probability of D. Probabilities of D will be counted by these two events because it is happening twice. It is not happening once, right? So either it is happening after A or it is happening after B. So first we will write probability of A times probability of D, this branch, this one, and then, or it happened B and then D, 0.6 times 0.7. So you will notice that one of the branches is B intersection D. All right. So it comes out to 0.42 in this case, and A was 0.4, Z 0.8, D 0.32. Yes. So 0.32 plus 0.42 will be 0.74. That is probability of D, only D. But this was our formula, so we will just divide 0.42, which was B intersection D. So this answer will be 0.42 divided by P, probability of D, we just got 0.74. So please do not oversimplify things and just take a branch and that is your answer. They will not give you 3 or 4 marks for just that. You have to completely do this whole process, and whatever answer they give me, I'm not interested in answer. I want to communicate to you what is the real process of finding conditional probability. So let's go to the summary. Do not focus on the language. If language says something and you just make a picture out of the tree diagram, don't do that. Keep the formula in mind and calculate individual parts and divide the way I have done it. I've done 0.42 divided by 0.4. This is how you should do it. Next, mistake 6 is about geometric probability distribution. People sometimes do not understand the language of the question or how to approach towards the solution. So the first thing, you should know that there are 3 types of questions which are asked in geometric probability. First, the success was on, say, 7th attempt, right? So that means before this, all 6 attempts were a failure. So what do? The probability of failure, which is Q, right? You will fail 6 times and then you will get the success on 7th time. This is how you interpret this. They will not tell you that someone failed 6 times and then he got success in 7th attempt, right? They will say success was on the 7th attempt for the first time. So you should understand that 6 times the person failed. So second type of question is that success was after 7th attempt. So they won't tell whether it was 8th attempt or 9th or 10th, we don't know, right? But it is sure that 7 attempts were failure. So in such case, you are sure about that 7 failures were there. This is your answer, q to the power 7. Do not bother what happened after that. 400% sure that after that it was success. So there's no need to write this one here. Q to the power 7 is the one when the language is like this, after 7th attempt. Okay? And third type of question is success was achieved within 7 attempts. That means again they're not telling you whether it was the first attempt, second attempt, third attempt, or 7th attempt. We don't know, right? But what we are sure about that the person did not fail in first 7 attempts. He certainly got a success within 7 attempts. So this was the failure of 7 attempts. In that case, we write 1 over q to the power 7. So the language, sometimes you have to interpret from the language of the question, otherwise you will not be able to give right answer. Geometric probability distribution answers are usually 1 or 2 steps if you understand the language very well. There is no summary for this. I think I am clear enough when I explained these 3 questions. Mistake number 7 is actually a recommendation from my side. If you do not draw the graph of a normal distribution, you are bound to make mistakes. So I always recommend that whenever there is a normal distribution question, please draw a graph and visualize where is the number. If the number is more than mu or less than mu, which direction it is, will it get a negative z-score, because we'll get a negative z-score on the left side and positive z-score on the right side, and we have only positive z-scores in our normal distribution table which is provided to us in exams. So draw a graph, normal distribution graph, before attempting any question. That's my recommendation. So it just is a recommendation. Mistake number 8. Sometimes they give you an x variable which has a normal distribution and then they give a number here, say 17 and 3. Okay, so students usually take this as mean and this as standard deviation because it is very small in number. 3 is very small. No, the second number is never standard deviation, it is variance. So for standard deviation, if you want to use a normal distribution, you have to use square root of 3, not 3. So this is a mistake. Please avoid this mistake in exams. And here's the summary full of caution. Square root variance, do not use it as it is. Mistake number 9 is also about normal distribution. Sometimes what happens then in question, they say that let's say this one, okay, and this is 80, the mean is 77. So they will say the probability that x is less than or equal to 80 is 0.78, right? They will say 0.78. So when people turn to the normal distribution table, they use this 0.78 as z-score, because you will definitely find 0.78 in the vertical column. Let me show you the picture. You can see here very clearly that there is 0.78. I don't think my cursor will be visible in video, but you can say 0.7 is on this column, Z column here, left side, and then 0.78 is here, 0.7823. Can you see? They're exactly similar. 0.78 is giving you 0.7823, right? But even if there's a difference of very minute number, you cannot use the probability you had as z-score. Sometimes the difference is too much. Okay, if you have 0.95, let's see if 0.95 is there. 0.95, yes. 0.95 will give you 0.8289. Can you see? So if you use Z score, probability as Z score, it will give you a totally different answer and you will not get a correct. In this case, they will mostly ask standard deviation. What is the standard deviation? You'll get a wrong answer in that case. And I hope the summary is quite clear. While using normal distribution, you should be very much sure what are you trying to find, Z-score or probability. Use your table accordingly. And the final mistake which I have observed is that normal distribution is for continuous data. Yeah? So you might have observed that if x is less than 50 or x is less than equal to 50. In both cases, we don't even bother whether this is an equal sign or not, right? Why? Because it's a continuous data. 50 is closer to 49.999, something like this, right? But when it comes to discrete data, we use normal distribution in case where NP is greater than 5 and NQ is greater than 5. I hope you are aware of this. Right? And it is usually a binomial probability distribution which we approximate with normal distribution in such case. But in the case of discrete data, it makes a lot of difference when you use equal sign and don't. So if probability is x is less than 50, right? That means the next number less than 50 is 49. So you will convert this to probability x is less than 49.5. You bring your calculations closer to the number you want. 49 is the number you want, so you come to 49.5. And if it is equal, probability of x is less than equal to 50. That is 50 is part of it. In that case, you will use x is less than 50.5. So your x will be used as 50.5 to find standard deviation or z-score in that case. I hope it's very clear that in discrete you add or subtract 0.5 depending on the boundary, the number they have given, maximum or minimum. Accordingly you do it. But in continuous, there is no need to add 0.5 or add or subtract 0.5. This is for discrete data only when we add or subtract 0.5. So the summary of this whole story is that shift your variable x by 0.5 based on condition only for discrete data when we are using normal approximation. All the best for your exam.